Hello. Today I will show you how to find and calculate a flame path. Calculate. So to calculate the flame path is related to EXT, only EXT. Equipment, motors, and the standard is 679-1. Make sure that you are using the same standard, the same version or year as the equipment, the marking on the equipment and the certification documents. The equipment we're looking at today is an EXT junction box. Look like this one. Try to rotate. So you see this is EXT 2B and T6 IP65 and with IEC certificate BKI 070018. So you need to have this certificate. And here is the certificate for the junction box we saw, same certificate number. BKI 070018. So down here you can see the standards this equipment are certified according to. And since this is EXT, so you see this is 679-1, and they use edition 5, 2003. So the standard we are using should also be the same year and same version. So here I have the EXT standard. See, 679-1, 2003. So this is the equipment, EXT equipment. I assume that you know what the EXT flame path and gap is. So this is, I'm going to show you how to find and calculate the flame path. So, as I know, most of the people, when they ask where's the flame path on this one, they automatically will show from here to here, a small one, from here to here. The flame path is always calculated from the shortest distance. So all of from here to here and here to here may not be the same distance. So when this equipment gets certified, the certification body, the test lab, they have calculated the flame path at the worst case. As you see, there's holes for the cover here. You have holes here, 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 this here, here, and here. So the flame path from here to here is much shorter. In case of internal explosion, the energy will escape here and going out to the hole. Yes, it's come out here and then go through the bolts. Oh. through the bolt outside, because this bolt has nothing to do with the flame path or protection of the flame path, except of course if you don't close the cover, and this will maybe have a larger gap here, then it also could be a problem. But this bolt, this fastener, is to withstand internal explosions. It has nothing to do with flame path. Now we're going to look through the standard, how to calculate the flame path, the length and the gap. So here's the EXD standard 679-1 and table 2. But this is for gas group 2C. As I showed you before, that this our equipment here is marked with 2B. So there's another table up here. You see this is 2B. You see 2B, 2A, and group 1. So the first thing you see, look at the table, you see you have maximum gap, and you have the minimum width of joint is the flame path, and what type of the joint. The one we're looking at is called flange joints. I assume you know the differences between the flange joints, cylindrical or spigot joints. So first, when we identify our type of joints, we need to, next step, you have to look at the volumes of the enclosure. So either you measure it, or you can have a look at the technical documents. If I see it here, I saw it in the technical document and the instruction manual. Very important that you have to look at the same type, correct type. This is ours, JB12R. You have the internal measurement, and you take this one and you have to make a calculation, so you get the internal volumes. It's around 900 cubic meter. So now we have this volumes is between below 100 cubic centimeter, between 100 to 500 cubic centimeter, and this is between 500 and 2000 cubic centimeter. And we have around 900, and it should be somewhere here. And we have group 2B, 2B. So if we have group 2B, so what is the minimum width of joint we must have? So now it's we have 12.5 and 25. Of course, I choose the minimum one is 12.5 millimeters. So you see you have volumes, you have what kind of joints, flange joints, you have the gas group, and here 0.2 is the minimum gap. But right now we don't look at the gap. We look at the minimum width is 12.5. So now we have 12.5. This means that the shortest one, you can have a longer one if you want to. The longer, the better it is. So, but when we talk about the EX, we always have to think about the worst case. And the worst case is the shortest path flame path where the energy will escape. So when we measure this one, this must be below no more than 12.5, this length from here to here. Assume that our internal volumes is correct. Now we said it's around 900 cubic centimeter. But if you also consider the internal components, so it should be less. So this is how you get to know the minimum requirement. So as you know now, is if these volumes without internal components is minimum 12.5 millimeter length in flame path, and in case this is the volume is between 100 to 500, it should be it can be minimum 9.5 length in the flame path. So now I think I've shown you how to find and how to calculate the flame path by using this table 1.